right, physics courses. This could be mine or Mr. Clonlim's. I'm going to show you guys how to do a little video analysis here. So, Logger Pro Resources is the name of the topic. You're going to go in here. You're going to get your download for Logger Pro. Follow that. Install it at home, Windows or Mac OS. If you need to do it here at school, you're going to have to come in 10th period to one of our classes or after school and do your video analysis here. You know, junior, seniors in high school, you get to the point where you probably should have a different computer other than a Chromebook, right? Either a Mac or a Windows machine. All right, anyhow, let's see here. So Physics C, I've already shared videos with you guys in our lab, kinematics. Physics 11, we'll be doing this soon. Perhaps even today. We did it, well, we did it, perhaps even today, we'll see. But anyhow, here we go, Physics C, here's your videos. I'm just going to pick one kind of at random, see what we got here, whose it is. Oh, this is Bracken trying to go super fast. Alright, so there's our video. We're going to download it. Hopefully this lets us do that. Okay, these aren't very big videos. Appears that autoplay quality, might be better, a little bit higher quality, but we'll see. Downloading it hopefully is full quality anyway. All right, so we downloaded it, right? Once we had it in here, then we open up Logger Pro. So this looks like a little older version than the one that I posted for you guys. Let me just go back and check that really quick while we're here. This is 3.14, 3.16. Probably doesn't look that different. So anyway, here's Logger Pro. You go to Insert Movie. All right, we'll find that one I just downloaded. Now, you have to shoot the movie correctly to start off with, right? That's the trick. You got to make sure you have some sort of scale in there, and you want to make sure you're far enough back so that you're, when you run across, the edges of the motion aren't being too distorted. If you're really close to the camera, then the edges tend to be distorted. But anyway, we were on the ball field. We got pretty far back. Oh yeah, look, this is a nice big high quality video. All right, so let's see what we have here. Let's play it. Now, it may not play very well in Logger Pro, the software, so don't be too nervous about that. See how it looks choppy? That's okay, because we really want to just look at all the cells. Now, it looked like it was wobbling a bit, and that's probably mostly because I was pushing start and stop on the screen. So hopefully while he ran across the screen, everything was okay. All right, so the first thing we want to do is kind of figure out where the first frame of our video is. All right. All right, too far. So here he comes. Now we also want to be able to track a consistent point on his body. Now his head is pretty darn well focused. He keeps it pretty upright. So I'm clicking these arrows down here just to advance through the slides. His head, man, I could even get his ear in this video. It's such good quality. All right, that's what I might do. If they're bouncing a lot, that can be tricky. But he's moving pretty fluid here. So shoulder could be good, ear could be good. This is a good quality video. So lots of sunlight. That's the key. The more light when you shoot one of these videos, the better. All right. So if you're ever doing this in the classroom, you want to make sure, for instance, you put the equipment here and have the camera here, so the light is shining onto the setup. All right. More light, the better. I think some of you probably remember doing video analysis last year. If you're in Physics C, you remember doing video analysis where it was hard to plot because it's so blurry. Well, the more light, the better. So first things first, set a scale right here. You click this little button down here, brings up the menu. Up here you have your different options. All right, set scale, this one. This is what I mean by having a scale. Like we had meter sticks, and we measured between, we measured 2 meters between these cones. Oops, so that's good. You got to hold down the mouse button. I'm used to engineering where you just, so those cones were centered 2 meters apart. 2.0 meters. All right. The wider you can make that scale, the less error there's going to be because of the, dragging the line over it. The other thing we do now is set origin. I'm going to make this our first point, and I'm going to track the student's ear. All right, in the positive direction. You might remember this, but if you grab this circle here, you can rotate it. It's easier to rotate if you move it. I'm holding the mouse button down as I do this, but I just want it to be flat right now. Hopefully you follow that. Now, before we go any further, we've set the scale, we've added our origin, then we're going to add points. But before we do that, we're going to go options, movie options. I'm just going to do 1 frame every point. I shot this 30 frames per second. All right, you can shoot 60, but that gives you more data points, but that's not necessarily a good thing. They might be blurrier, each individual frame, because it's trying to shoot more per second. First VA point times 0 multiple times. Okay. First VA point defines movie time 0. We click that. So the first time I click in here, it's going to make that our 0 time. All right, like that's when the clock will start. I'm only going to move it 1 frame after adding a point. If something's moving very slowly, you might make that 2 frames. If it's moving really slow, you might make that 5 frames. Or if you, shot in high quality 60 frames per second, you might change that. And if you're changing that to only add points every, other frame, then just shoot in 30 frames per second. And those are options on your camera when you go to take a video. Anyway, I'm just going to leave it 1 right now. See how it goes. So now I'm going to start adding points. And this should be pretty straightforward. I'm just going to click the student's ear as he moves across. No, I'm using the ear just because it's a well-defined point. And we got lucky in the quality of this video. Often it's not this good. You just gotta kind of click the middle of their shoulder. Sometimes what we might do, and look, his head is going down a little bit and up a little bit, but that's okay. Sometimes what we'll do is actually physically put a reference point on whatever it is we're tracking. If you ever seen a crash test dummy, right? You may have seen one before. They always have like weird black marks on them. They almost look like bullseyes and stuff. Those are reference points for video analysis, believe it or not. I don't think they use vernier. They usually have some sort of scale in the video, from what I've seen. But they can use those marks on the test dummy to plot. Now, I'm starting to see his back, So it'll be interesting to see if this graph bends anywhere. So there we go. It kind of bends at the beginning. So I plotted the points. Now what? Well, we got to see our graphs. We go page, auto arrange. And as you get good, you'll learn how to do this. Control R will be a good one. And I usually make the video a little smaller. New page, auto arrange again. All right, that kind of makes everything fit nice. Note, we have 2 different position versus times here. X position and Y position. All right. I want to just look at the X direction of motion here. All right. I might actually go and rotate this axis. Now be careful clicking. Whatever button's highlighted here, that's what the cursor is going to do. So if I click now, it's going to add a random point and totally mess up your graph. And if you mess up your graph by misclicking and you hit Control Z, it really slows everything down. So I'm going to click the origin here. Grab that handle. I'm just going to put it along that. So that tells me that either the camera was crooked or it wasn't quite tilted the right way in the vertical plane. But the line looks really straight for position versus time, so we should be in good shape here. Note what that did. It just kind of shifted the Y position, the vertical position the Y is, just to be flat the whole time. And the individual points are nice because what we've been talking about in class, this goes with, right? Like position versus time graph shows you where the person was located along a straight line as a function of time. All right, so now over here, I don't want to see the Y, so I right click. Actually, I think I can just double click on that. I just want it to be X. I don't want the Y. Now, I also want to see the velocity versus time graph. How do I do that? Well, you go up here to Insert Graph. It says Y velocity. I want to see the X velocity versus time. Oh man, that looks terrible. Let's see what it actually looks like, though. Page Auto Arrange. Velocity versus time graphs can be deceiving when you first put them in there, because look at our range here. This is zoomed in from 5.5 only up to 7.5. So if we right click here, I did a right click, I do auto scale from 0. That looks better, right? Now, the velocity is pretty constant at about 6 meters, a little over 6 meters per second. If you hit up here, you can do a fit line by clicking this button. So I click that, I click that, fit line. Notice it auto scaled. I'm going to do the same up here at fit line. Right click, auto scale from 0 again. Now the fit line tells us some things, right? And this is pretty much what we do with video analysis. Is the slope of this line is about 6.3 meters per second. Note that the value of the velocity is about 6.3 meters per second the whole time. Now, was he accelerating? Maybe he was. Or maybe what happened was the camera was tilted. So if it was tilted a little bit, right? If the right side of the camera is tilted back a little bit, it's hard to explain this, but distances along the line he was running would look bigger. So if the right side of the camera is tilted back a little bit, distances on the right side of as you move to the right across the frame would look bigger than they are. Or actually, I guess, yeah, it would look bigger than they are. Or maybe, bigger. Which would make it look like he accelerated. Hard to say what happened there. This graph really does show us. It looks very linear. From the position versus time graph, we can tell if something's accelerating, right? If it's linear, then it was a constant velocity. If it's clearly curved, then it was accelerating. And this is not clearly curved. It's linear, almost 1.0 correlation, so that's very good. All right, so now you're going to do this for the other videos. All right, so Physics C, this is the specific instructions for using the software for our lab. But the rest of the physics course is just an overall view on how to do video analysis. If you want to print these graphs, if you want to print this whole screen, you go, it's nice to do page setup and then put it on landscape before you print it, right? So you do this in class or at home. Print footer's nice because oftentimes your graphs look a lot alike, and whoever's printing it, it's good if you put your name in there because it actually will print it at the bottom for you. And then you hit OK. I'm going to send it to the color printer. What the heck? And we're off. All right. So yeah, basic video analysis. Hopefully everybody can follow that. If you have any questions, let myself or Mr. Clonman know. Talk to you later.